We are starting now question number 5 for this topic of kinematic for mechanics. The diagram shows the velocity time graph for the motion of the two particles P and Q, which travels in the same direction along a straight line. P and Q both start at the same point X on the line, but Q starts to move t seconds later than P. Each particle moves with the speed of 2.5 meters per second, and for the next 20 seconds for its motion, the speed of the each particle changes instantaneously to 4 meters per second, and it has been moving for 20 seconds, and then the particles continues to move at the same speed. Part 1. Make a rough diagram, copy of this diagram, and shade the region which represents the displacement of P from X at the point when Q starts. It is given that P has traveled 70 meters at that instant when Q starts. Find the value of T. Then find the distance between P and Q when Q speeds reach 4 meters per second. And the last part is sketch the single diagram showing the displacement time graph for both the particles P and Q with the values shown at the time t seconds and which the speed of each particle changes. Since the particle P is represented by full line and the particle Q is represented by dotted lines, the first part is we have to show the displacement time graph for the particle P till the particle Q is going to start its motion. So up till 20 seconds, the speed of this one is 2.5 meters per second. And from 20 to 20 seconds, its speed is 4 meters per second. So if we draw the graph of the displacement, that's its time. This one is displacement. Then up till here, it is 20 seconds. And up till here, the distance is 20 into 2.5 is 50 meters. Then from this point till this point, when t is there, because they have not mentioned the value of t there, but the value in between of this graph is speed is 4 meters per second. So this will be for the next t second is the graph of this particle p, and then the particle q is going to start after this value of t there. In the next part, it is given that P has traveled 70 meters at the instant when Q starts. Find the value of T there. And also find the distance between P and Q when Q speeds reach 4 meters per second. Since in the second part, you are going to find out the value of T there, where it has traveled 70 meters for this particle P. So we know that for the particle P there, area of this portion is the distance traveled there. So that thing is equal to 20 into 2.5 and up till here t. So this time will be equal to t minus 20 because this length is t minus 20 and into this speed is 4 there. So we can multiply by 4 into t minus 20 and that distance total is traveled, they have mentioned, equal to 70. So this thing will be equal to 50 plus 40 minus 80 is equal to 70, or 40 is equal to 150 minus 50. 40 is equal to 100, or t is equal to 25 seconds. So this is the value of t which they are going to calculate in the second part of this question statement there. In the third part, they are asking that how much distance traveled when P and Q are going to reach at the speed of 4 meters per second there. So first distance traveled by P there is known as to be equal to 50 plus this is 25. So this distance total is difference is 5 there into 4. So that is into 20 plus 4 is the speed there into 45 minus 25 is 20 there. So distance traveled by P particle is 50 plus 20 plus 80. So that thing is equal to 150 meters. Distance traveled by Q particle, that is equal to this 45, this 25. So that is 20 into 2.5. So that thing is equal to 50 meters. So distance between these two, so that is equal to 150 minus 50, and that is equal to 100 meters. And in the last part, fourth part, let's say it is displacement, this is time. So we have from this first rectangle, so it will be this distance up till 20, and it has covered distance of 50 meters. Then it is again the second part is also a rectangle but with a slight steeper slope. So it should be like this. So this is 25. Let's say that is 45. This is the distance traveled by particle P there. Since Q is going to start after 25 seconds, so after 25 seconds, the particle Q is going to start. First, it will move like this, and then its parallel to this slope will become like that. So this is the distance of Q there. So this is the graphs of these two when they are shown parallel to each other. The displacement time graph for particle P and Q there.